Okay, I was going to work through some of the problems from 6.2. These are some that we did in class, actually quite a few of them. Let's start with 26. Now 26, if you look at it, what they've actually done is they've already factored that for us. So you might look at that and be tempted to go ahead and multiply it out, but really remember when you see more than one trig function, which this one you didn't see, but it would have had, you want to get it equal to 0 and factor it. So basically, they've already factored this one. So the next step after that, after you get it equal to 0 and it's factored, is to set each factor equal to 0. So we have cosecant x plus 2 equals 0, and cosecant x minus radical 2 equals 0. Now you're going to solve those as if they were their own problem. Now remember, the first question we always ask is how many trig functions? Well, in this one, there's only one trig function. And all these steps are on the top of the 6.2 page of notes. They're also on top of the 6.3 page of notes, same steps. So when you see one trig function like this one, first you want to isolate it. So we move the 2 to the other side. Now here, the next thing we usually do is do the inverse trig function. Well, if you're not comfortable working with inverse cosecant, we can change that to sine. If we convert that to sine, well, we know sine is the reciprocal of cosecant. So if the cosecant is -2, the sine is the reciprocal of -2. So it looks like that. Well, now we can do the inverse sine of both sides, because the next thing to do is get rid of that sine. So we do the inverse sine. Now we have x equals the inverse sine of -1/2. Now remember, this means what angle has a sine of -1/2. Well, if it's negative, we can put it down in the fourth quadrant. Sine is opposite over hypotenuse. Well, that's one of our triangles. That side would be radical 3. So our angle right here, opposite 1, that's pi/6. You can tell we're in radians because it has an x in it. So our reference angle is pi/6. Well, it's a negative. Well, sine is negative in the fourth quadrant, so we can call that negative pi/6. And remember, for sine, we add the period for sine, which is 2 pi k. Sine is also negative over here in the third quadrant. Well, if we put pi/6 over here, then this will be 1 pi, which is 6/6, plus another 6, that'll be 7/6. Remember, with sine, you find two quadrants. So here's our two quadrants, because sine is negative in the fourth quadrant and in the third quadrant. So that's where those two answers came from. Now let's do the other part after we factored. Here again, there's a single trig function, so we want to isolate it. So let's move the radical 2 to the other side. Now again, if you don't like dealing with inverse cosecant, we can convert that to sine. Well, sine is the reciprocal of the cosecant. So now we do inverse sine of both sides because we want to get rid of that sine. So x equals the inverse sine of 1 over radical 2. Well, 1 over radical 2, that's positive. If we put it in the first quadrant, that'd be opposite over hypotenuse. Well, that's a 45, 45, 90 triangle. So we know our reference angle is pi/4. So x equals pi/4 plus 2 pi k. That's in the first quadrant. Sine is also positive in the second quadrant. If we put pi/4 in the second quadrant, then this whole angle would be, all the way here would be 1 pi, which is 4/4, back a fourth, which is 3/4. So that's our two quadrants. Again, with inverse sine, you find it in two quadrants, and then you add 2 pi k or 360k, because that's the normal period for sine. Now the last thing on this one, it says find all the answers that are between 0 and 2 pi. So we just go through what we have. We start here with a negative pi/6. Is that in our interval? No, because there's no negatives. But we add 2 pi. Think of 2 pi as 12/6. Well, 12/6 plus a -1/6 is 11/6. Is that in there? Yes. So that's one of our answers. What if we add another 2 pi? So we add another 12/6. That's 23/6. That's too big. Move down here to 7/6. Well, 7/6 is between 0 and 2 pi, so that's an answer. If we add 2 pi, which is 12/6, 19/6 is too big. That's bigger than 2 pi. Now we move over here, pi over 4. Well, that's between there, so that's an answer. If we had 2 pi, well, that's 4, add an 8/4. That'd be 9/4 pi. Well, that's bigger than 2 pi, so that doesn't work. Move down here to 3/4. That fits, so that's an answer. If we add 2 pi, so we add 4 sets, add 8/4, that's 11/4. That's too big, so those are our 4 answers. Okay. Let's look at 27. So you look at that, first thing we look is how many trig functions you see. Well, it looks like 1 because there's sine, but because this one's sine and this one is sine squared, that counts as 2. So we want to get it equal to 0. Well, this sine squared is negative. I like sine squared to be positive, so I'm going to move it right. So since there's more than one trig function, we got it equal to 0. Now, we see if we can factor that. Well, if you look at that, that's a quadratic. It's got a squared, it's got a single, and it's got a constant. So let's see if that'll factor like this. Well, 2 factors of 2 are 2 and 1, and there's a sign with it, so we can put 2 sine x and sine x. The only 2 factors of 1 are 1 and 1. Well, if we check, if we do the multiply here, that's 2 sine x. In the middle, that's 3 sine x, or I'm sorry, 1 sine x. That adds up to 3, so it works out. So it factors like that. So we factored it. Now we set each factor equal to 0. So 2 sine x plus 1 equals 0, and sine x plus 1 equals 0. Now we solve each one of them separately. So you look at this one, there's only one trig function, so we isolate it. So we want to subtract 1, and then divide by 2. Now we want to get rid of sine, so we do the inverse sign. So this says, what angle has an inverse sine of negative 1/2? Well, we already did that on the previous problem. The inverse sine of a negative 1/2 gave us negative pi over 6 and 7 pi over 6. So we'll just shortcut and say, yeah, we got that already. So negative pi over 6 plus 2 pi k and 7 pi over 6 plus 2 pi k. Now for this other half here, again, we have a single trig function, so we want to isolate it. So let's move the 1 to the other side. Now to get rid of sine, we do the inverse sign. So this says, what angle has a sine of negative 1? Well, the only time sine and cosine are 1 or negative 1 is on the quadrantal angles. So if you think of our 4 spots, where does y, remember sine is y over r, so where is y equal negative 1? Well, y equals negative 1 right down here. So our answer is, you could use a negative pi over 2, you could use 3 pi over 2, either one is fine. Let's say we call that, let's go all the way around, let's call that 3 pi over 2 plus 2 pi k. Now normally we have 2 quadrants for sine, but since this is quadrantal and that's the only place where it equals negative 1, here we just have one answer. Now again, we're finding all the answers between 0 and 2 pi, so we just go through them again. Negative pi over 6, well, that's too small, it's negative. If we add 2 pi, again, that's 12/6. That'd be 11/6, that fits, so 11/6 is an answer. If we add 2 pi, another 12/6, that's 23/6, that's too big. Go down to 7/6, well, that fits in there, so 7/6 is an answer. If we added 12/6, that'd be 19/6, that's bigger than 2 pi. Go over here, 3 pi over 2, that fits, that's an answer. If we added 2 pi, that's like adding 4 halves, that's 7 halves, that's way too big. So it's just those 3 answers. Okay. Let's go to 29. So let's see, sorry, sine squared cosine theta equals cosine theta. Now you look again, how many trig functions? Well, I see a sine, cosine, so it's more than one, so we need to get it equal to 0. Let's say I move that cosine to the left side. And whenever you see more than one trig function, you want to get it equal to 0. Now we look to factor. Well, the first thing you look for is a common factor. Well, these have a cosine in common. Let's factor that out. So we're going to divide, if we divide this in by cosine, we're left with sine squared divide this in by cosine, we have 1. Now we have it factored. Let's set each of those equal to 0. So cosine theta equals 0, and sine squared theta minus 1 equals 0. So here, there's only one trig function. It's already isolated, so the next thing is to get rid of cosine, we do the inverse cosine. So this says what angle has a cosine of 0? When it's 0, it has to be a quadrantal angle. Remember, cosine is x over r, so we're looking for where x equals 0. Well, in our quadrantals, x equals 0 up here and down here. So that could be a positive 90, and that'd be 90 degrees, so we could use 90 degrees. Whoops, leave a space here. You have two choices really here. If we just take 90, and we're in degrees here because we have theta. Remember, with cosine, if we just find one answer, we can put a plus or minus in front. So you could do that on this one, since it's quadrantal. You could put 90 and 270 also. That'd be the same as putting plus or minus 90. Okay, if we do this other side, we still have a single trig function, sine squared. We know when to isolate it, so we move the 1 to the other side. Now to get rid of the squared, we square root both sides. So sine theta equals plus or minus the square root of 1, which is 1. Don't forget the plus or minus. Now to get rid of sine, we're going to do the inverse sine of both sides. So here, this is two sets of answers. What angle has a sine of 1? Well, that's going to be where y equals 1. That y only equals 1 up here. So that'd be 90 degrees plus 360k. Now we also have what angle has a sine of negative 1? Well, y equals negative 1 down here. So that'd be 270 plus 360k. So we're up to there right now. Now we're trying to find all the answers that are between 0 and 360. So again, we just go through them. We have a positive 90. Well, that fits between 0 and 360. If we added 360, 450 is too big. A negative 90. Well, there's no negative number, so that doesn't work. But if we added 360, that's 270. That fits. If we added 360 again, 630, that's too big. So now go over here, 90. We already had a 90, so we don't have to worry about that. If we add 360, that's too big. 270, we already have that one. If we add 360, it's too big, so these are our only two answers. All right, let's look at 30. And when you look at that, You see it has more than one trig function because I see a secant and a tangent. When there's more than one, we get it equal to 0. So let's move them. It doesn't matter. Let's say I move it left. So I'm going to have secant squared theta, tangent theta, minus 2 tangent theta equals 0. Remember, with more than one trig function, we want to get it equal to 0. Now we want to factor it. Well, these have a tangent in common. Let's factor out a tangent. If we divide this by tangent, we get secant squared. If we divide this by tangent, we just get a negative 2. So we have it factored. Then we set each of the factors equal to 0. So set tangent of theta equals 0, and secant squared theta minus 2 equals 0. Now we're going to work each one of those separately. Here on this one, there's a single trig function. It's already isolated. To get rid of tangent, we do the inverse tangent. So we have theta equals the inverse tangent of 0. Remember, that means what angle has a tangent of 0? Well, tangent is 0 whenever y is 0, because it's y over x. Well, that happens at 0 and at pi, or here we're in degrees. So it happens at 0 and at 180. We can, if we want, just put 0. With tangent, you only need 1, because remember, the normal period for tangent is 180. So we're going to add 180k instead of 360k. Now we go to the other one. We have a single trig function. We need to isolate it, so we move the 2. We need to get rid of that squared, so we're going to square root both sides. Again, don't forget the plus or minus. So now we have this. Now, if you don't want to do inverse secant, we can convert this to cosine. Remember, secant is the reciprocal of cosine. So I can say cosine is the reciprocal of the secant. So it would look like that. Well, now when we do inverse cosine, so theta is the inverse cosine of plus or minus 1 over radical 2. So cosine could be a positive 1 over radical 2. Well, that's a 45-degree angle. So 45 degrees. Remember, for inverse cosine, we put a plus or minus in front and a 360k in the back. Now this says theta is also the angle whose cosine is a negative 1 over radical 2. Well, cosine is negative in the, sorry, I've lost it here. Cosine is negative in the second quadrant. If you put 45 in the second quadrant, that would be 180 minus 45 is 135. So 135, again, plus or minus in front, 360k in the back. Now we're trying to find all the answers between 0 and 360, so we have 0. If we had 180, that fits. If we had 360, it doesn't quite fit. Remember, we're going between 0 and 360. So move over to this one. 45 fits. We had 360, 405, too big. Negative 45 doesn't fit. But if we add 360, that's what, 315? That fits. If we add 360 again, 675, too big. Go to this one, 135, that fits. Add 360, 495, too big. Go to a negative 135. No negatives. If we add 360, that'd be what, 225? That fits. If we add 360 again, 585, too big. So those are our answers. All right. The last one, let's do 31. So if we look at that, how many trig functions are there? Well, there's a cosine and a cosine squared, so more than one, so we need to get it equal to 0. So let's move the 1 to the other side so it looks like that. Now if you look at this, I see a squared, a single, and a constant. So you think, when we go to factor it, that's a quadratic. Unfortunately, it just doesn't factor. So when it doesn't factor, if it's a quadratic, we can still use the quadratic formula. The only difference is in algebra, you had x equals the quadratic formula. But here, our variable is actually cosine theta. So we start with cosine theta equals. Well, now we have our a, b, and c. So the quadratic formula says take negative b, so negative 4, plus or minus the square root of b squared, so that's 4 squared, minus 4 times a, which is 4, times c, which is a negative 1, all over 2a. So that's the normal quadratic formula, nothing different. Negative b plus or minus the square root of b squared, minus 4 times a times c, all over 2a. The only difference is, instead of x equals, we have cosine theta equals. So now we need to simplify this up here. So negative 4. This would be negative 4 times 4 is a negative 16. That's plus 16. So under the radical, we have 16 plus 16, which is 32. So it looks like that. Now you might try to simplify that, but you really don't need to and probably shouldn't. For us to find out what the angle, this isn't going to be one of our triangles, so we're going to have to use our calculator. So there's no sense simplifying if we're going to plug that into our calculator. So it looks like we're in degrees. So we want to make sure we're in degrees. And we're just going to do that on our calculator. So there's two of them because of that plus or minus in front. So first let's do the positive one. So negative 4. Negative 4 plus, you can see that, the square root of 32 divided by 8. I get 0.207. 0.2071. It's 0.2071. Now let's do the minus one also, because it could be minus in there. So negative 4 minus the square root of 32 divided by 8. I get negative 1.2071. So we have those two possibilities there. Now that's cosine theta equals that. So the next thing is we need to get rid of cosine, so we do the inverse cosine of both sides. So we're going to have the inverse cosine of 0.2071 and the inverse cosine of negative 1.2071. So if we do that top one first, so if I take the second cosine of 0.2071, it tells me it's 78.0 degrees. So this one is 78.0. This is cosine, so we're putting a plus and minus in front and a plus 360k in the back. Let's do this inverse cosine the next one. So inverse cosine of negative 1.2071. It's going to say error. The reason it says error is, here you notice our cosine is past 1. Remember, cosine is never past 1. So that's why this one has no solution to it. So we just have this. Well, now we need to find everything that fits again between 0 and 360. Well, start with 78, that fits. If we add 360, 438, too big. Go to negative 78, that doesn't fit, no negatives. Add 360, we add 360 to that. Or on this one, did I say find all solutions? I don't remember. No? Oh no, sorry. So if we add 360 minus 78, we get 282. So that's our two answers there. All right, so that's just how to do some of those on 6.2. We'll finish working on those. We should have started working on 6.3, and hopefully we can finish those up next Monday.